Number 19 on your review asks you to compute this integral. The contour is the contour that goes from 0, 0 out to 1, 0, up to 0, 1, and then back down. So I've drawn it in there. Now, if I were to do this line integral in the traditional way, I would have to parameterize this segment, and the third segment, and then do 3 separate integrals. But luckily, we have Green's theorem, and the suggestion in this problem is to use Green's theorem to solve this integral. So let's get Green's theorem up there. Green's theorem is if I want to find the integral of f dot dr, then this is equal to the double integral over the region here. So this is my region. And I put in the integrand del f2 del x minus del f1 del y. And we do the integration with respect to area here rather than doing around the boundary of the contour. So this will make things easy for us. The f1 and the f2 are as follows. This is your f1 and this is your f2. So del f2 del x, that's where I take the derivative of this with respect to x, I get y. Del f1 del y, that's where I take the derivative of this with respect to y, that just gives me 0. So this integral here this is the integrand, that's equal to just y when I put those two together. So let's set this integral up. I need to know the bounds of the integral. This is going to be the integrand, it's just y. So I'll go back over here and set the integral up. Now y is going from the bottommost graph, which is y equals 0, up to this graph here, which is y equals 1 minus x. So I'm going to integrate from, y is going to go from 0 to 1 minus x. I'll integrate dy first. And then after that I do x. And what is x ranging from? It's ranging from 0 out to 1. So that completes the setup of my integral. Now I have to actually do the integral. So, okay, let's integrate this. I get y squared over 2 from 0 to 1 minus x. Once I've completed doing that, I'm going to integrate from 0 to 1 with respect to x. On the inside here, I get 1 minus x squared over 2 dx. The antiderivative of this is going to be 1 minus x cubed, and now I raise this to the third power and then I divide by that 3, so that combine that with the 2, I get 6. And then if you just check here, if I were to take the derivative of this to get back to that, then what I would do is I multiply in front by the 3, that would give me a 2 on the bottom, that's okay, but I'd also get a minus, so I need to put that out there as kind of a preemptive strike so that I make sure that I get back to what I started with. Okay, so there's my integration, and I'm going to evaluate that from 0 to 1. Be careful here, don't just automatically assume that when you plug in 0 it goes away. It's actually the opposite here. When you plug in 1 it goes away. So what this is equal to is 0 minus negative 1/6, which is positive 1/6.